All right, let's look at this question from JAMB of 2013. It's a past question. It's on geometric progression. All right, so it says if the sum of the first two terms of a GP is 3 and the sum of the second and third terms is -6, find the sum of the first term and the common ratio. I repeat, if the sum of the first two terms of a GP is 3 and the sum of the second and third terms is -6, find the sum of the first term and the common ratio. Now for a GP is given by this formula, the nth term. So the nth term, this stands for the position of every term. So we have, so this is the formula for the geometric progression, right? So where A is for the first term, R is our common ratio, all right? And then N will be the position we are looking for the term. So A R raised to power n minus 1 is the R raised to power n minus 1. All right, so the question says the first two terms of a GP. So the first term is A, the next term is AR. So this is the first plus the second term. If you put 2 into 2, where you have n, put 2 minus 1 becomes R raised to power minus 1, R raised to power 1. So this is first term plus second term. All right, then this is second term plus third term. So that's how it goes. First plus second equals 3 from the question. All right, so basically we have, all right, so this is the sum of the first two terms of a GP is 3. So the first plus the second term is 3. That's the sum. All right, then and the sum of the second and third terms is -6. So this is the expression for the second term of a GP. This expression for the third term of a GP. Remember, if you put 3 here, if for the third term n becomes 3, so 3 minus 1 gives us AR squared. So AR squared is the expression for the third term, and we are told that the sum is -6 for the second and the third term is -6. So it creates a simultaneous equation. You can divide equation 2 by 1. Divide this 1 by, okay, divide equation 2 by 1. So all of this is equation 2 by 1. It's easy for you to divide if you factorize. So let's factorize this equation 1. See, AR is a common factor, so AR divides into AR, we have 1. AR divides into AR squared, we have R. So we factorize equation 1. Also factorize equation 2. Factorize equation 2. Actually, equation 2 is on top and equation 1 is under. So equation 2 looks like this. Equation 1 looks like this after being factorized. So you see 1 plus R is common to both equations. Now we are dividing. That's why we have this dividing line. So we divide equation 2 by. So we have the dividing line because we are dividing equation 2 by 1. We are dividing so just to simplify, okay? So 1 plus R cancels out. 1 plus R. All right. So at this point, 1 plus R is common to the factorized expression. So 1 plus R can be cancelled out. I just want to say that with GP we tend to multiply and divide, while with AP we tend to add and subtract. So you see, so this can cancel this out. This cancels out, and we're left with AR over A equals to -6 over 3, which is -2. Also A cancels out. Remember, A is also going to cancel out. So we're left with R equals to -2. So we've gotten our common ratio as -2. Simply by dividing equation 2 by 1 or even equation 1 by 2, you still get the same answer. So we can substitute -2 for R in either of the equation, either this equation 1 or 2, which has been factorized. Okay, so substitute -2 for R in either equation 1 or equation 2. You can choose equation, this is equation 1, this is equation 2. But it's preferable to use the factorized version, which is, this is the factorized version, this one, AR into 1 plus R for equation, yes, equation 2, or A into 1 plus R. So let's use A into 1 plus R, is simpler. So if you put -2, look at it, the factorized version, put -2 here, you see that 1 plus R becomes 1 minus 2, then that's -1 times A, which is -A equals to 3. Divide both sides by -1, you have A equals to -3. So with that, we have A equals to -3 and R equals to -2. You sum them, you get -5, all right?